There are some common pitfalls here, and so I will point those out where we run into them because I've seen a lot of students make these mistakes. All right. So again, we're going to be looking for the lowest ratio. So you're going to be given percents most of the time. And the easiest way to deal with the percents is just pretend that you have 100 grams, because then it's a direct one-to-one conversion from percents to grams. We need to get grams, and then we can take grams and go to moles. Now, if for some reason they actually give you the grams to start with, then you can skip this step. You've got grams right away, and then you can take grams to moles. But usually you're given percents of each element. But again, if you're given grams of each element, then you're that much closer. All right, and then so what we're going to do with the grams is we're going to take the molar masses off the periodic table and then figure out the moles of each element present. Now that's probably not going to give you a very clean ratio. So what we're going to do is we're going to divide all the mole amounts by the lowest mole value present. And I'll show you what that means. And that should clean up your ratio first, and then we can manipulate the ratio from there. And what I like to say is that we don't really round these ratios. We'll tweak them as needed. And so a good thing to ask yourself is, well, you might end up with things that aren't a whole number. And so what we'll try to do is kind of nudge a little bit so that we can get these things that can then be multiplied out to whole numbers. And so if something ends up being 0.5 moles, well, that's okay, because we'll just double everything and that'll get us to whole numbers. What you don't want to do is round up 0.5 moles, because that's going to ruin the ratio. And so same with 1/3 or 2/3, we can multiply that by 3. It's very rare, and I can't think of any situations off the top of my head where you'd run into 1/4 or 3/4. But if we did, we could try multiplying those out. But remember, these percents are actually going to lead to a real empirical formula. So if you're struggling with this to get it to work out, you probably did something wrong in your math. And so, as Willie points out here, figuring out this empirical formula is a bit of an art form. It's going to take a little bit of practice and a little bit of confidence. But once you get the hang of it, it's really not that bad. So let's walk through an example of this right now. And so let's say something's 63% manganese and 37% oxygen. What's the empirical formula? Well, the way I would start that is I take those percents and convert them straight over to grams. Just change the unit to percent. Percent to grams. And then we can take those grams and divide each of those by the molar masses. So this is sort of the opposite of what we did for determining molar mass. We're going to take the grams and go back to moles. So now we're going to be dividing by the molar mass off the periodic table, and then we get our mole ratio of 1.1 moles of manganese to 2.3 moles of oxygen. Now the first mistake I see very often is that students don't keep track of which is which element. So they'll go through all the work and then they will end up assigning the wrong mole value to the wrong element, and that would be a big mistake. So this isn't quite clean, so let's clean it up. The smallest of those two numbers is 1.1, so we just divide both of them by 1.1 and clean up the ratio. Now, by the way, one of the common mistakes I also see is for somebody to take the 1.1 and the 2.3 and then add them together. Because based on muscle memory, when they determined molar mass, that's exactly what they did. They added up the grams to get the total amount of grams. But adding up the moles will do nothing for you. It's totally the wrong thing to do, so avoid that temptation. So anyway, I clean up my ratio, and then I end up with a 1 to a 2.1 ratio. Now that's close enough that I can just kind of tweak that a little bit. So 1 to 2.1 becomes a 1 to 2 ratio. Now really in a problem like this, you really don't have to worry about sig figs, because in the end you're just going to round them to whole numbers anyway. So we can be a little loosey-goosey with sig figs on a percent to empirical problem.